Welcome to this lecture on variables in Java. Last time we created our basic Hello World program in Java, and we learnt that we create a class and we put code inside of that class. We also learnt that this public static void main gets called as the first part of our application or the entry point to it. Now, let's remove this system.out.println and let's just leave main. I'll create a bit of space in here, and we first have to talk about variables. What is a variable and why would you want to know what it is? Well, the why is easy, because variables are the smallest building blocks of all programs. They're like the really small, tiny Lego pieces that you stick in key places in your models. What are variables? Variables are basic pieces of information. Now I can say to you, here is number 9. Remember the number 9, and you remember it. If I ask you to write the number 9 down, you can write it down. If I ask you to put it in your phone, you can do that too. But the thing is, with programming, we can say to it, remember the number 9, but we have to tell it what kind of thing the number 9 is. And that is the essence of a variable. It's a kind of thing. So let's start with our number 9 example, which is called integer. An integer is simply a whole number, like 1, 2, 3, 4, or -4, -36. And the way we declare a variable integer in Java is by typing int, and then put a space in, and then we type the name of the variable. So let's just call this the letter A, and if we want to make it equal to something, we can type equals 9. And then in Java, we put a semicolon at the end of our line to indicate it has finished. Now our program holds this variable A, which has 9 stored in it. Of course, you can do the same with int B is equal to 10. Let's hit compile, and everything compiles nicely. There are no errors. Now, what if I want a decimal number? Well, let's try int C is equal to 9.87. Now hit compile. Ooh, and we have an error. And whenever we hit compile inside of any IDE, what we're doing is we're asking the program to translate this to code that can be run and interpreted. And if it finds a problem, it will tell you. And this is good, because you don't want problems to happen when someone else has your code, because when that happens, your code crashes and the whole program gives up. So it's much better to find your errors now. Right, down on the bottom, we have possible loss of precision. Required int found double. Okay, what does that mean? Well, this is a pet peeve of mine, and it's that whenever we compile things, it gives us cryptic messages if we are beginners. If you're an experienced programmer, then this is no problem to understand. What this is saying is that the integer C on this side cannot hold something with a decimal point in it. It can only hold a whole number. So it could hold 987, but it cannot hold 9.87, because integers are simply whole number stores. So how do we get around that? Well, we can change int to something called a double. And a double, if I click compile, does allow us to store a decimal. There are many different kinds of ways of storing numbers in your programming, and each of them has their limits. If you're doing really big maths, you probably want to try a double or what's called a long. Alternatively, if you have lower numbers, you can define what's called a float. Float d is equal to 9.86. Now let's see what happens if I compile. We have an error, and that's because floats need to have an f at the end of them. And when we click compile, everything works fine now. So always remember that doubles don't require anything added to the number. Floats require an f at the end. Now, whilst we're on the subject of numbers, what we're going to do is print out these numbers and see what our system says they are. So we want system.out.println. Open your brackets and let's output C first, and then let's copy that over, drop it in, and then output D. Now I'm just going to change D to 9.87, so these are nominally the same number. I'll hit compile and then run. And that's correct. They're both the same number. Now you may ask why I've done that. Well, in the subsequent lectures where I go into operators like addition, subtraction and multiplication, you're going to see why I did that and why it's important to know what kind of numbers you're working with. Right, I'm just going to remove these system outlines and go over two more variable types that you really need to know about. The first of which is, what if I want to store something like a 1 or a 0, true or false? Well, there's a special type for that, and that is called a Boolean. Let's call this E is equal to, and we define it by writing true or false. And these kind of things help us to keep track of the state of an application. For example, if I was playing music and I hit the play button, I would say Boolean is playing is equal to true, so I know my music is playing. If I hit the pause button, I would say Boolean is playing is equal to false, because the music is no longer playing. So these are very handy to help you keep track of what's happening. Finally, what if we want to store a word? Well, that is simply string f is equal to, and then we open up our quotes and put our word in, close our quotes and put the semicolon in. Now we have what's called a string. And a string holds a bunch of text for us. Now, one final thing before we end this lecture is we cannot mix these types of variables. So I cannot say integer g is equal to name, because if I try and compile that, I get this horrible error that says, hey dude, you can't put a string where I'm expecting an integer. And of course, this works both ways. So if I try to write string g is equal to 7 and I compile it, I have the same error, just the opposite way round. It requires a string, yet I gave it an integer. So just know you cannot mix and match your variable types. And this is called typing when we program. Not typing as in the keyboard, but it means that our variables have to stay or be put in a particular kind of box. Okay, that's pretty much all there is to these simple variables. There is a lot more as we go on through the course, and you'll see we can expand on this idea of variables, so stay tuned for that. But in the meantime, that is variables covered.